Good morning, students. This is the third video of chapter 2 is matter around us view. So, let's start our first topic, that is separating the components of a mixture, or we can say separation of mixture. As you know, many of the materials around us are mixtures. Clear? These mixtures have two or more than two substances mixed in them. It may not be possible to use a mixture as such in homes or in industries. So, we may require only one or two separate substances of a mixture for our use. So, we have to separate the various mixtures into their individual constituents to make them useful in our daily life. The various constituents of a mixture have different physical properties, and that physical properties such as density, solubility, size of particles, behavior towards magnet, boiling points, etc. This difference in the physical properties of constituents is used to separate them from a mixture. So, the method to be used for separating a mixture depends on the nature of its constituents. Different mixtures are separated by using different processes. Different processes such as sublimation, magnet, filtration, centrifugation, evaporation, crystallization, chromatography, distillation, fraction distillation, and separating funnel. So, our first topic is separation by evaporation. Now students, what is evaporation? The changing of a liquid into vapors or gas is called evaporation. Evaporation is used to separate a solid substance that has dissolved in water or any other liquid. The dissolved substance is left behind as a solid residue when all the water or liquid has evaporated. So, the use of process of evaporation for separating a mixture is based on the fact that liquids vaporize easily, whereas solids do not vaporize easily. Let's take the example C in figure A and B. The solution of common salt and water is taken in a china dish and heated gently by using a burner. The water present in salt solution will form water vapors and escape into the atmosphere. When all the water present in the solution of common salt and water gets evaporated, then common salt is left behind in the china dish as a white solid. See the figure B. Now, second example is separation of dye from ink by the process of evaporation. So, we take a beaker and fill it half with water. About 5 ml of ink, blue or black, is put in a china dish. The china dish containing ink is then placed over the mouth of beaker containing water, which is kept on a tripod stand. Just see the figure A. We now start heating the beaker with a burner. Soon the water in beaker starts boiling to form steam. This steam heats the ink in the china dish. Due to this, heating, the water present in ink starts evaporating gradually. When all the water has evaporated from ink, now we stop heating. We will find that a small amount of a solid colored material is left in the china dish. Just see the picture B. This colored material is the dye which was present in the ink. So water has evaporated from the ink and solid dye is left behind. This experiment shows that ink is not a single substance or pure substance. It is a mixture. So, ink is a mixture of dye in water. Clear? Let's move our next topic, that is separation of two immiscible liquid. And it can be done by separating funnel. Separation by a separating funnel. A mixture of two immiscible liquids can be separated by using a separating funnel, shown in figure. A separating funnel is a special type of funnel which has a stopcock, or we can say tap, in its stem to allow the flow of a liquid from it, or to stop the flow of liquid from it. The separation of two immiscible liquids by a separating funnel depends on the difference in their densities. We will now describe how a mixture of two immiscible liquids is separated by using a separating funnel. The mixture of two immiscible liquids is put in a separating funnel, okay, and allowed to stand for some time. After some time, the mixture separates into two layers according to the densities of the liquids in it. The heavier liquid, or we can say denser liquid, having higher density, forms the lower layer, whereas the lighter liquid, having lower density, forms the upper layer. See in figure. On opening the stopcock of separating funnel, the lower layer of heavier liquid comes out first and collected in a beaker. When the lower layer of heavier liquid has completely run off, the stopcock is closed. Now, the lighter liquid in the upper layer is collected in a separate beaker by opening the stopcock again. For example, water and kerosene oil. These are the two immiscible liquids. So, a mixture of water and kerosene can be separated by using a separating funnel. When the mixture of water and kerosene is put in a separating funnel, it forms two layers. Water being heavier forms the lower layer in the separating funnel, whereas kerosene being lighter forms the upper layer. On opening the stopcock of separating funnel, the lower layer of water comes out first and collected in a beaker. When the water layer has completely run off, then the stopcock is closed. The kerosene is left behind in the separating funnel. It is mentioned in the figure. So, it can be removed in a separate beaker by opening the stopcock again. Okay, please note that there are two differences in the properties of oil. For example, kerosene oil, mustard oil, and water, which enable their separation by a separating funnel. These are: oil and water are immiscible liquids. Oil and water have different densities. A mixture of more than two immiscible liquids can also be separated by using a separating funnel. For example, a mixture of mercury, water, and benzene can be separated in this way. When a mixture, now centrifugation, separation by centrifugation. If we have a mixture of fine suspended particles in a liquid, we can separate it by the process of filtration by using a filter paper. This process is, however, very slow, but we can separate the suspended particles of a substance in a liquid very rapidly by using the method of centrifugation. It is done by using a machine called centrifuge. We can now say that centrifugation is a method for separating the suspended particles of a substance from a liquid in which the mixture is rotated or spun at a high speed in a centrifuge. For example, separation of cream from milk. Milk, as you know, milk is a suspension of tiny droplets of oil or cream in a watery liquid. The process of centrifugation is used in dairies to separate cream from milk. The milk is put in a closed container in big centrifuge machine. Let's see the diagram. When the centrifuge machine is switched on, the milk is rotated at a very high speed in its container. Due to this, the milk separates into cream and skimmed milk. The cream, being lighter, floats over the skimmed milk. It can then be removed. Thus, cream is separated from milk by centrifugation. Another example, the process of centrifugation is also used in washing machines to squeeze out water from wet clothes and make them dry. Now, separation by chromatography. Chromatography is a technique of separating two dissolved solids which are present in a solution in very small quantities. There are many types of chromatography, but the simplest form is the paper chromatography. So, we will study only paper chromatography. Okay. For example, black ink contains a number of dyes dissolved in water. These dyes have different solubilities in water. This fact is used to separate the dyes present in black ink. The different colored dyes present in black ink can be separated by performing a paper chromatography experiment as follows. Just see the figure A, B, C and D. First, take a thin and long strip of filter paper. Draw a pencil line on it, about 3 cm from one end. Now, put a small drop of black ink on the filter paper strip at the center of the pencil line. See figure A. Let the ink dry. What happened? When the drop of ink has dried, the filter paper strip is lowered into a tall glass jar containing some water in its lower part. Keep the pencil line at the bottom. The filter paper strip is held vertically by attaching its upper end to a glass rod with sellotape. Please note that though the lower end of the paper strip should dip in water, but the pencil line should remain above the water level in the jar. See figure B. Now, the water gradually rises up the filter paper strip by capillary action. As water moves up the paper strip, it takes along the dyes present in ink. The dye, which is more soluble in water, dissolves first, rises faster and produces a colored spot on the paper at a higher position. The less soluble dyes dissolve a little later, rise slower and form colored spots at lower heights. In this way, all the dyes present in black ink get separated by forming separate different colored spots. See figure C. When the water reaches near the top end of the filter paper strip, the paper strip is removed from the jar and dried. The paper with its separate colored spots is called a chromatogram. See figure D. The chromatogram obtained by using black ink in this experiment has 3 colored spots on it. This means that the given sample of black ink has 3 different dyes mixed in it. Just see the figure D. Chromatography is an important tool in chemical analysis. It is used to separate small amounts of dissolved substances. Some of the important applications of chromatography are: it is used to separate solutions of colored substances, means dyes and pigments. Chromatography is used in forensic science to detect and identify trace amounts of substances like poisons in the contents of bladder or stomach. Chromatography is used to separate small amounts of products of chemical reactions. Clear? Now, separation of the gases of the air. Students, as you know, air is a mixture of gases like nitrogen, oxygen, argon, carbon dioxide, helium, neon, krypton, and xenon, etc. The major component of air is nitrogen, about 78.03%. The second major component of air is oxygen, that is 20.99%. And the third major component of air is argon, that is 0.90%. All the remaining gases of air constitute only 0.05% of air. Nitrogen is used for making fertilizers. Oxygen is used for making steel in factories and in hospitals. Argon is used in electric bulbs. So, all these gases are obtained from air on a large scale. This is because air is the cheapest source of these gases. The various gases of air are separated from one another by the method of fractional distillation. This separation is based on the fact that the different gases of air have different boiling points. We will now describe how gaseous air is converted into liquid air and how the three major components, nitrogen, oxygen and argon, are separated from it. Air is separated into its component gases in the following steps. Just see the figure, a flow diagram showing the main process involved in obtaining different gases from air. So, the first step is the air is first filtered to remove dust, and then water vapor and carbon dioxide are removed. Okay. Now, after that, air is compressed to a high pressure and then cooled. This cooled air is then allowed to expand quickly into a chamber through a jet. This expansion cools the air even more. Third, the process of compression, cooling and rapid expansion of air is repeated again and again, making so cooled that it turns into a liquid. In this way, liquid air is obtained. Fourth step, the liquid air is fed into a tall fractional distillation column from near its bottom and warmed up slowly. Here, liquid nitrogen, that is present in liquid air, has the lowest boiling point of minus 196 degrees Celsius. So, on warming, liquid nitrogen boils off first to form nitrogen gas. This nitrogen gas is collected from the top part of the fractional distillation column. Liquid argon, that is also present in liquid air, has a slightly higher boiling point of minus 186 degrees Celsius. So, liquid argon boils off next and collected as argon gas in the middle part of the fractional distillation column. Now, liquid oxygen has a still higher boiling point of minus 180 degrees Celsius. So, liquid oxygen boils off last and collected as oxygen gas from the bottom of the fractional distillation column. Okay.